Good morning, my dear students. In this particular video presentation, we will continue with the remaining problems from exercise 7.3 on integration of NCERT textbook. The first problem, that is the fifth one in that exercise, goes like this. Integral sin cube x cos cube x dx. What I will do is, I will write this as sin cube x cos square x into cos x. I will write this as cos square x into cos x dx. Cos square x into cos x dx. I will write this as sin cube x into 1 minus sin square x into, this can be written as d of sin x because derivative sin x is cos x. Now I can very well write this as t cube into 1 minus t square dt, where my t is sin x. Therefore this becomes t cube dt minus integral t power 5 dt, which is t power 4 by 4 minus t power 6 by 6 plus c, which is anyway sin power 4x by 4 minus sin power 6x by 6 plus c. Let me just repeat once again. Integral sin cube x cos cube x dx is the question given to you. I can very well write it as integral sin cube x cos square x into cos x dx, which is equal to integral sin cube x cos square x can be written as 1 minus sin square x, and derivative sin x is cos x. Therefore d of sin x cos x dx can be written as d of sin x. Whenever I have d of, I should multiply dx also. I told you in one of the videos earlier. Now whatever is written as d of will be my substitution for t cube into 1 minus t square dt, where t is equal to sin x. It's written into as two integrals, integral t cube dt minus integral t power 5 dt, t power 4 by 4 minus t power 6 by 6 plus c. For sin power 4x by 4 minus sin power 6x by 6 plus c is the final answer. You have a second method for the same problem. Just see here. Integral sin cube x cos cube x dx can be written as integral cos cube x into sin square x and multiply 2 minus signs here. This can be written as minus integral cos cube x into 1 minus cos square x into d of cos x. Derivative cos x is minus sin x. Therefore, I multiply 2 minus signs in the second step. Now, this can be written as t cube into 1 minus t square dt, where here my t is different. Here my t is cos x. Earlier it was sin x. Here it is cos x, where my t is cos x. T is equal to cos x, which is minus integral t cube dt plus integral t power 5 dt, can be written as minus t power 4 by 4 plus t power 6 by 6 plus c, which is minus cos power 4x by 4 plus cos power 6x by 6 plus c. You can just verify whether my answer is right or wrong. Integral sin cube x cos cube x dx. I bring cos cube x to the beginning. Sin cube x can be written as sin square x. Since derivative cos x is minus sin x, I multiply 2 minus signs in this step, the second step. Can be written as minus integral cos cube x into 1 minus cos square x into d of cos x. D of the quantity will be my substitution always. Minus integral t cube into 1 minus t square dt, where t is cos x, minus integral t cube dt plus integral t power 5 dt minus t power 4 by 4 per t power 6 by 6 plus c. Minus cos power 4x by 4 plus cos power 6x by 6 plus c is the final answer. There is another method for the same problem. This is the third method. Integral sin cube x cos cube x dx. Multiply and divide by 8 here. 8 sin cube x cos cube x dx can be written as 1 by 8 into 2 sin x cos x the whole cube dx, can be written as sin cube 2x dx. Now let me just recall the formula of sin 3a. is 3 sin A minus 4 sin cube A. Therefore, 4 sin cube A becomes 3 sin A minus sin 3A. Therefore, sin cube A automatically becomes 3 by 4 sin A minus 1 by 4 sin 3A. Let me just continue here. I'll rub this side. I'll continue with the remaining answers of this same problem. Let me just, because the space is not enough over there, let me just continue here. Therefore, 1 by 8 integral sin cube 2x dx will now become, you end up with 3 by 32, 8 fours are 32, integral sin 2x dx. Then of course minus 1 by 32 integral, it is sin 6x dx. 3 into 2x becomes 6. Instead of a I have 2x. So this is getting reduced to minus 3 cos 2x by 64. Then plus cos 6x by, this becomes 192 plus c. 6 2s are 12, 6 3s are 18 plus 1, 19, 192. This is anyway cos. I'll rewrite if you want. I will rewrite. This is nothing but cos 2x. Let me just explain once again. Integral sin cube x cos cube x dx. Multiply and divide by 8 over here, because 2 sin x cos x whole cube is nothing but 8 sin cube x cos cube x. 2 sin x cos x is nothing but sin 2x. Let me get the formula of sin cube A in terms of sin 3A from sin 3A. Let us not by heart that directly. Sin 3A is 3 sin A minus 4 sin cube A. 4 sin cube A is 3 sin A minus sin 3A. Sin cube A is 3 by 4 sin A minus 1 by 4 sin 3A. Now 1 by 8 integral sin cube 2x dx becomes, instead of A I have 2x here. 3 by 8 into 4 is 32. 3 by 32 integral sin 2x dx minus 1 by 32. 8 4s are 32. Sin 3 into 2x becomes 6x. But sin 2x, the integral is minus cos 2x by 2. Because derivative for minus cos 2x is plus sin 2x into 2 I'll have. Now minus 3 cos 2x by 64. This minus is taken inside. Plus cos 6x by 6 into 32 becomes 192. 6 2s are 12. 6 3s are 18 plus 1 19. It's correct. Okay. This is how it is being done. But you need not worry. In all the three cases, the values can be equated using basic trigonometric formula. It's better to know all the methods. It's better to know all the three methods. Better to know all the three methods. All the three are correct. Even here you can simplify further. I can write sin cube 2x is sin square 2x is sin 2x, and multiply and divide by minus 2 again there. Then minus 2 sin 2x can be written as df cos 2x, and that sin square 2x can be written as 1 minus cos square 2x. Now use t is equal to cos 2x and proceed. Here again I am getting another method. Therefore there are so many methods for the same problem, especially when a problem is there on trigonometric functions. You will have here, I have given you 4 different methods for the same problem. I have given you 4 different methods for the same problem. Last one, what I explained, you can try on your own, the way which I explained. Only 3 I have done on the board, on third, fourth one I just explained simply. Then the next problem goes like this. This is the 6th problem. He says integral sin x sin 2x sin 3x, sin x sin 2x sin 3x dx. Just multiply and divide by 2. 2 sin x sin 2x into sin 3x dx. Now 2 sin a sin b can be written as cos a minus b minus cos a plus b. Therefore I end up with cos x minus 2x minus cos x plus 2x into sin 3x as it is. We can write the formula cos a minus b minus cos a plus b is equal to 2 sin a sin b if you want. Now this is nothing but integral cos x sin 3x minus integral half into half is already there. Integral cos 3x sin 3x dx. This is cos x anyway, sorry. Cos 3x sin 3x dx. Now again multiply and divide by 2. 2 cos x sin 3x dx minus 1 by 4 2 sin 3x cos 3x dx. Here I can very well write this as, see here, 2 cos a sin b is nothing but sin a plus b minus sin a minus b. Sin x plus 3x minus sin x minus 3x dx. Am I right? Check and then write. Check once again if you want. If anybody is copying down, better you check and then copy down, or just listen to the steps carefully. Now I'll be using 2 sin a cos a as sin 3a, sin 2a. So this will become sin 6x dx. Therefore this is again gets reduced to 1 by 4 sin 4x dx minus plus 1 by 4 integral sin 2x dx minus 1 by 4 integral sin 6x dx, because sin minus theta is minus sin theta. Therefore this is reduced to minus cos 4x by 16, then minus cos 2x by 8 plus cos 6x by 24 plus c. Let me check the whole answer once again. You are given integral sin x sin 2x sin 3x dx. Multiply and divide by 2 and clap the first two terms. 2 sin a sin b cos a minus b minus cos a plus b is 2 sin a sin b. Cos x minus 2x minus cos x plus 2x into sin 3x is as it is. 1 by 4 integral cos x sin 3x dx minus 1 by 2 integral cos 3x sin 3x dx. X plus 2x is 3x, x minus 2x is minus x, with cos minus theta is cos theta. I write it as a positive quantity. Multiply and divide by 2 again in both the terms. 1 by 4 integral 2 cos x sin 3x dx minus 1 by 4 integral 2 sin 3x cos 3x dx. But sin a plus b minus sin a minus b is 2 cos a sin b. Therefore sin x plus 3x minus sin x minus 3x dx minus 1 by 4 2 sin a cos a can be replaced by sin 2a. Sin 2 into 3x 6x. 1 by 4 integral sin 4x dx plus 1 by 4 integral sin 2x dx, because sin minus theta is minus sin theta, minus 1 by 4 integral sin 6x dx. Recall integral sin ax dx is minus cos ax by a in general. Instead of a I have 4, instead of a I have 2, instead of a I have 6 here. Now minus cos 4x by 4 4s are 16. Minus cos 2x by 4 2s are 8. Taking this minus sign inside, plus cos 6x by 24, or minus of minus cos 6x becomes cos 6x by 24 plus c. It is not at all a difficult task. Understand, please understand, and then proceed with the similar problems if you come across. Integral sin 4x sin 8x dx. Multiply and divide by 2. 2 sin 4x sin 8x dx. Now already I told you 2 sin a sin b is cos a minus b minus cos a plus b. Therefore cos 4x minus 8x minus cos 4x plus 8x dx. Make it into 2 integral. This is cos 4x dx minus integral cos 12x dx. Cos minus theta is cos theta. Now this can be replaced by sin 4x by 8 minus sin 12x by 24 plus c. Let me just check once again. Integral sin 4x sin 8x dx is a question given to you. Multiply and divide by 2 in the second step. Cos a minus b minus cos a plus b is 2 sin a sin b. Therefore cos 4x minus 8x minus cos 4x plus 8x dx. This integral half integral cos 4x dx minus half integral cos 12x dx. 4x plus 8x is 12x. 4x minus 8x is minus 4x, but cos minus theta is plus cos theta. Therefore, I write it as simply 4x here. Integral cos ax in general is sin ax by a. Instead of a, I have 4 here. Instead of a, I have 12 here. Sin 4x by 4 2s are 8. Minus sin 12x by 12 2s are 24 plus c. You can just verify here. It is cos 4x into 4 I have. Therefore, divide by 4. If you differentiate this, I'll be able to get whether I'm getting the given function by which I started with. That is how the answer for any integration is checked. The final answer when we differentiate should give us the function by which I started with. That's the real meaning of integration. Integration and differentiation are reverse processes to each other. Therefore, differentiation of my final answer should give us the function by which we started with. That is how it is supposed to be done. Then the question number 8, it goes like this. Integral 1 minus cos x divided by 1 plus cos x dx. 1 minus cos x divided by 1 plus cos x dx. Now this can be written as 1 minus cos 2 into x by 2 by 1 plus cos 2 into x by 2. I will be able to write. Now this is nothing but 2 sin square x by 2. This is nothing but 2 cos square x by 2 dx. 1 minus cos 2a is 2 sin square a. 1 plus cos 2a is 2 cos square a. This is integral tan square x by 2 dx can be written as secant square x by 2 minus 1 dx can be written as integral secant square x by 2 dx minus integral dx. This is nothing but tan x by 2 by half minus x plus c, which is nothing but 2 tan x by 2 minus x plus c. Let me just explain once again. Integral 1 minus cos x by 1 plus cos x dx is the question given to you. This x can be written as 2 into x by 2 in both the cases, in both numerator and denominator. 1 minus cos 2a is 2 sin square a, 2 sin square x by 2. 1 plus cos 2a is 2 cos square a, 2 cos square x by 2. 1 plus cos 2a is 2 cos square a. 2 gets cancelled. Sin square by cos square become tan square, the same value. But for tan square, there is no direct formula. Can be written as secant square x by 2 minus 1 dx. Integral secant square x by 2 dx minus integral dx. Here I have tan x by 2 by derivative of x by 2 should be divided. Half minus x plus c. Our 2 tan x by 2 minus x plus c is the final answer. It is almost 18 minutes. Anyway, I will continue with the remaining in the next video. Thank you students for patient work.